Welcome students. Today we will learn chapter 12 Heron's formula. This formula is basically using for finding area of a triangle when the length of its all the three sides are given. Before discussing this Heron's formula, let us discuss about area. For this, for an example, this be a triangle ABC on this flat surface means flat board. When we draw this triangle ABC on this flat surface, this plane divided into three parts. First part of this blackboard outside this triangle, which is called exterior region. Second part, which is inside this triangle, which is called interior region. And third part of this plane, which is inside this triangle, which is called triangle itself. It means this whole area, this whole space divided into three parts: exterior region, which is outside this triangle; interior region, which is inside this triangle; and this triangle itself. When we find area of this triangle, then area of this triangle means the space occupied by this interior region and this triangle itself. For finding area of this triangle, we have a basic formula. When base and corresponding altitude of a triangle are given, then area of triangle that becomes area of triangle ABC, that becomes half base into corresponding altitude. Altitude means height. Students, this word corresponding is very important. This base and this altitude, height of this triangle must be corresponding to each other. As you know that in case of a triangle, students, we have three vertices, three sides and three interior angles. These three sides and three interior angles, these are the parts of triangle. Vertices are not the part of a triangle. Similarly, in case of a triangle, we have three altitude with respect to each base. If we assume this BC as base, then corresponding altitude or height of this triangle becomes a perpendicular from opposite vertex to BC. It means, say, AD be the perpendicular from vertex A to side BC, then this AD becomes altitude of this triangle with respect to this side BC, and area of this triangle becomes half BC into AD. If we assume this AC side as base, then corresponding altitude of this triangle becomes a perpendicular from this opposite vertex B to this side AC, say this be BE. And now area of this triangle, assuming AC as base, that becomes half AC into BE. This BE is the altitude or height of this triangle with respect to this base AC. And if we assume this AB as base, then altitude of this triangle becomes a perpendicular from this point C, this opposite vertex C, to this side AB, and that becomes, say, CF. And now area of this triangle ABC becomes half base AB into corresponding altitude CF. As you see here students, all these three altitudes of this triangle with respect to each side as base passes through the same point. So we can say that all three altitudes of a triangle are concurrent, and this point of concurrency, a point through which these all three altitude passes, this point is called orthocenter. The unit of area is always square unit. It means if the base and corresponding altitudes are given in centimeters, then area of this triangle becomes centimeter square or square centimeter. If base and corresponding altitudes are given in millimeters, then area of this triangle becomes meter square or square meter. Now we come to our main topic, Heron's formula. How can we find out area of a triangle when the length of all the three sides of that triangle are given? For an example, let again there is a triangle ABC in which length of this side A is say A unit, length of this side B small b unit, and length of this side AC that becomes C unit, small c. Then here, since length of all the three sides are given, so for finding area of this triangle, first of all we have to find out small s. Small s means semi-perimeter, and semi-perimeter means students half of the perimeter. As you know that perimeter of a triangle is sum of length of all the three sides. So semi-perimeter becomes sum of length of all the three sides BC plus CA divided by 2, and it becomes A plus B plus C upon 2. Since we are assuming length of side AB as small a unit, length of side BC as small b unit, and length of side CA is small c unit. And now area of this triangle ABC, that becomes square root of s into s minus a into s minus b into s minus c, this much square units. Okay students, now let me try to make you understand this Heron's formula with the help of an example. Find the area of a right triangle ABC, right angled at B. Find the area of a right triangle ABC, right angled at B, in which AB equals to 3 centimeter and AC equals to 5 centimeter using Heron's formula. Here we have to find area of a right triangle which is right angled at B, in which the side AB is given 3 centimeter, side AC is given 5 centimeter using Heron's formula. For this students, first of all, we draw a right triangle ABC, which is right angle that B. In this right triangle, this side AB is given 3 centimeter, and this longest side opposite to 90 degree, which is called hypotenuse, that is given 5 centimeter. Since Heron's formula is applicable only when the length of all the 3 sides are given. So here in this question students, first of all we apply Pythagoras theorem so that we can find out length of this third side BC. According to Pythagoras theorem, square of this longest side hypotenuse, that is equals to square sum of squares of other two sides. So here according to Pythagoras theorem, in this right triangle, ABC APPT, according to Pythagoras theorem, this AB square plus BC square equals to CA or AC square. Put the value of AB and AC here, so that becomes 3 square plus BC square equals to 5 square. 3 square, that becomes 9, plus BC square equals to 25. This BC square becomes 25 minus 9. When we subtract this 9 from left hand side to right hand side, it becomes negative, and this BC square becomes 16. And when we find the value of BC, that becomes square root of 16, which is plus minus 4. But since length never be negative, so we ignore this negative sign, and BC becomes 4 centimeter. Okay students, so length of this side BC, that becomes 4 centimeter. Now we know length of all the 3 sides of this triangle. So after using this Heron's formula, we can easily find out area of this triangle ABC. For this, first of all, we have to find out semi-perimeter. Now semi-perimeter is small s, that is equals to A plus B plus C upon 2. Length of any one side of this triangle we can assume as A, B or C. Order doesn't matter here students. So let if A equals to 3, B equals to 4 and C equals to 5, then this semi-perimeter becomes 3 plus 4 plus 5 divided by 2, and that becomes 12 divided by 2 means 6 centimeter. And now area of this triangle, ABC, that becomes square root of s into s minus a into s minus b into s minus c. So it becomes 6 into 6 minus 3, 6 minus 4 and 6 minus 5, this much centimeter square. Since lengths of sides are given in centimeter, so area becomes this much centimeter square. And after simplification, it becomes 6 into 3 into 2 into 1, and that becomes square root of 36, and which becomes 6 centimeter square. Again we are ignoring minus 6 because area never be in negative. So area of this triangle using Heron's formula, that becomes 6 centimeter square. You can also find out area of this triangle using your basic formula of half base into corresponding altitude. If you assume students this BC as base, for this BC, this AB which is perpendicular from opposite vertex to this side BC, this becomes altitude, and area of this triangle becomes half BC into AB, and that becomes half 4 into 3, 12 upon 2, again 6 centimeter square. So this is one example based on Heron's formula, students. This is all about for today. In next session, we will discuss more examples based on this Heron's formula. So thank you very much, students, and have a nice day.